Over 16 million tons of pasta are eaten worldwide each year, and this Italian factory helps meet that demand by producing over 10 billion boxes of spaghetti annually. This massive facility produces 60% of the country's pasta, totaling 330,000 tons per year. While it makes 110 pasta types, this video focuses on how it creates the most popular, spaghetti. The process begins with a massive delivery of wheat. A train with 20 cars brings in about 150 tons of it. This wheat comes from many parts of the world, and since each batch can be slightly different, they are carefully mixed to make sure the pasta always tastes the same. Wheat arrives at the factory in large shipments and is stored in temperature-controlled silos that hold up to 600,000 tons. Each batch undergoes an 8-hour quality check before processing. Since only wheat and water are used to make dried pasta, quality is crucial. The wheat travels 200 meters to a massive 7-story mill, Europe's largest, where it's inspected for weight, moisture, protein, and color. Defective grains are removed, and the rest are blended for consistency. Vibrating separators then eliminate any remaining impurities like straw or stones. After cleaning, the wheat is soaked in water for 30 hours. Once it's fully soaked, it's ready to be ground into semolina, the special flour used to make pasta. The grinding takes place in a rotating mill that breaks open the hard outer shell of the grain to release the pale yellow endosperm inside. But the challenge doesn't end there. Now, the semolina must be separated from the rest of the grain. This is done using a powerful sifting system. The grain is shaken through a series of filters that gradually separate the fine semolina from any remaining dust or husk. 8 of these machines operate non-stop, 24 hours a day, 7 days a week, and can process up to 34 tons of wheat per hour. Once the pure semolina is ready, it's sent to the production area. It first passes through a hopper, then drops into a high-speed mixer where it's combined with water to form dough in just 5 to 10 seconds. This machine can mix between 1 and 2 tons of semolina per hour. The biggest challenge at this stage is avoiding lumps. To solve this, each grain of semolina is soaked in water before entering the mixer. Inside, the dough is shaken with intense vibrations, stronger than even an expert Italian chef could manage, until it becomes soft and smooth, like a pillow. After 20 minutes, the dough is fully mixed and ready to be shaped into spaghetti. Next, the dough goes to the extrusion stage. It is pushed through special metal plates called dies that have holes shaped to create spaghetti. The dough comes out in long, thin strands and is cut to the right length by fast-spinning blades, forming a curtain of pasta over a meter wide. The machine uses 2 die blocks and presses the dough through them at 100 times normal pressure, producing 11,000 spaghetti strands every minute. That's 83,000 meters of spaghetti. As the spaghetti strands come out, they are laid onto moving rails and cut into 65-centimeter pieces. At this point, the pasta still contains about 30% water. It's important to dry the spaghetti properly to prevent mold and ensure it stays fresh. The pasta is sent into large dryers with 6 tons leaving the production line every hour. These dryers work like a giant version of a clothesline. In the past, spaghetti was dried in the open air for 3 days, using the warm breeze. Today, the process is far more advanced and efficient thanks to modern technology. Huge metal machines handle the drying process, which is so energy-intensive that the factory uses enough electricity to power 30,000 homes. The pasta begins a 10-hour journey through what is essentially a massive industrial dryer. In the first hour, heat removes 10% of the pasta's moisture. Over the next 9 hours, the spaghetti goes through 3 more heating stages until it reaches its final moisture level of 12%. This slow and careful drying process is what gives boxed spaghetti its long shelf life. The temperature and timing are strictly controlled to make sure the pasta doesn't crack or become too brittle. This also helps ensure it cooks properly without breaking. After drying, the spaghetti reaches the final stage of production where it's cut to length. In the past, spaghetti was sold in 50-centimeter strands, but today it's cut to 25 centimeters to make it easier for consumers to cook and store. Next, the spaghetti is sent to a lab for detailed testing. Technicians check the thickness, gluten levels, color, and even perform an al dente test to make sure it cooks just right. Once it passes all tests, the spaghetti is ready for packaging. A computer system measures the exact amount for each package. The pasta travels down a chute, and a moving container fills the packages with the right amount. The machine can fill 10 bags of 4 kilograms each in just 1 minute, and up to 60 bags per minute if needed. Each day, 100 tons are shipped out, with 65% going abroad, enough to make 30 million pasta dishes every day. This yogurt factory has produced over 3.2 billion bottles since it first started. The yogurt production process begins with fresh milk being heated and mixed with healthy bacteria to turn it into yogurt. After the yogurt is ready, it goes through a filling machine. This machine quickly pours the yogurt into bottles, one after another. Once filled, the bottles move down a line where they are sealed with caps. After sealing, each bottle gets a label with the brand name and important information. Finally, the bottles are packed into boxes and stored, ready to be sent to stores. The factory works fast and clean, making sure every bottle is safe and fresh. Donut production in factories is a streamlined process designed to produce large quantities efficiently while maintaining quality. The process begins with the preparation of the dough, which involves mixing precise quantities of flour, sugar, yeast, eggs, and other ingredients in industrial mixers. The dough is kneaded to achieve the desired elasticity and then left to rest and rise, allowing the yeast to activate. Once the dough is ready, it is transferred to a cutting machine, which shapes it into the classic donut rings or other desired forms such as filled donuts. The shaped dough is placed on trays or conveyor belts and allowed to proof in a controlled environment where it rises further to achieve the light, airy texture characteristic of donuts. The proofed donuts are then fried in large industrial fryers, filled with oil maintained at the perfect temperature. The donuts are cooked evenly on both sides, resulting in a golden brown exterior and soft interior. After frying, they are cooled and moved to the decoration stage. Depending on the type of donut, they may be coated with glazes, dipped in chocolate, dusted with powdered sugar, or filled with cream or jelly. Finally, the donuts are packaged for distribution, ready to delight customers. In large factories, millions of chickens are processed each day to meet consumer demand. Upon arrival, chickens are humanely stunned to ensure they do not feel pain before being quickly slaughtered. Their feathers are then removed using a hot water bath followed by a picker machine with rotating rubber fingers that pluck the feathers. Next, the chickens are thoroughly washed with high-pressure water and food-safe solutions to remove dirt and bacteria. Their internal cavities are also flushed with water to eliminate blood and tissue. The feet are removed first, followed by the internal organs, which are carefully extracted using a specialized cutting tool and suction system. Each chicken is inspected by plant workers for diseases or defects. Only a small percentage are rejected. The rest move through an automated system that precisely cuts and separates them into parts like breasts, drumsticks, and thighs, which are then packaged and delivered fresh or frozen to stores. As we continue, let's take a look at orange juice production in factory. The process starts with selecting fresh oranges. These oranges are washed thoroughly to remove any dirt or chemicals. Next, they go through machines that squeeze out the juice, separating it from the peel and seeds. The juice is then filtered to remove any pulp if needed. To keep the juice fresh, it is pasteurized by heating it quickly and then cooling it down. After that, the juice is packed into bottles or cartons, sealed and stored in cold conditions before being sent to stores. Orange juice factories follow strict quality checks to ensure the juice is safe and tasty for everyone. Have you ever wondered how your favorite cookies are mass-produced in a factory? It all starts with choosing the finest ingredients. Factories use high-quality flour, sugar, butter, and other essentials in bulk. These are precisely measured using automated systems to ensure consistency in every batch. In industrial mixers, the dough is created. The mixing process is carefully controlled to ensure the perfect blend of wet and dry ingredients. Once the dough is ready, it's transferred to specialized machines designed to shape the cookies. Whether it's traditional round cookies or fun shapes, the dough is rolled, cut, or pressed into molds. The shapes then move along the conveyor belt, ready for the next step in the journey. Next comes the most crucial part: baking. The shaped dough travels into large commercial ovens, where temperatures are perfectly regulated to bake the cookies evenly. These ovens can handle thousands of cookies at once. As the cookies bake, their flavors are sealed and their textures come to life, whether crispy or chewy. It all depends on precise timing and temperature control. Once the cookies come out of the oven, they're sent to a cooling area. This helps them set, ensuring that they maintain their structure and don't crumble when packaged. Each cookie undergoes strict quality checks to make sure it's up to standard before heading to the packaging line. Now that the cookies are cool, it's time to pack them up. Advanced packaging machines quickly and efficiently wrap the cookies, ensuring they remain fresh and undamaged during transportation. And here we have a beverage factory. Cans are filled and packaged through a systematic process to ensure quality and freshness. Empty aluminum cans are cleaned and sterilized to remove any dust or impurities. They move along a conveyor belt to the filling station, where machines pour in the drink. The amount of liquid is carefully measured to avoid spills or underfilling. Next, the cans are sealed with airtight lids to keep the drink fresh and prevent leaks. They then pass through a quality control check, where machines or workers inspect them for any defects. After sealing, the cans move to the packaging stage. Expiration date are added. The cans are then packed into cartons or plastic-wrapped packs for easy transport. Finally, the packaged beverages are loaded onto trucks and sent to stores, ensuring they reach customers in perfect condition. The journey of making doner kebab starts with fresh meat. Factories source high-quality lamb, beef, or chicken, depending on the type of kebab being made. Each batch is carefully inspected for freshness and quality before it's prepared for seasoning. Once the meat is selected, it's trimmed and portioned to remove excess fat and prepare it for seasoning. This ensures that every piece of kebab is lean yet flavorful. The next crucial step is seasoning. Kebabs get their rich signature flavors from a blend of spices and herbs. Factories use large industrial mixers to evenly coat the meat with a mix of ingredients like garlic, onion, cumin, coriander, and paprika. This process not only adds flavor, but also helps tenderize the meat. Tumblers ensure that the spices are evenly distributed, so every bite is packed with that signature kebab taste. Once the meat is seasoned, it's time to skewer it. In small batches, workers manually skewer the meat, carefully layering each piece. For larger production runs, machines take over skewering thousands of kebabs per hour. Automation plays a key role in maintaining consistency. Each kebab is packed tightly, ensuring it cooks evenly and holds its shape during grilling. Next, the skewered kebabs head to massive grills or ovens. Depending on the type of kebab, they may be slow-cooked over open flames or roasted in industrial ovens to lock in that smoky, juicy flavor. This step is crucial for giving kebabs their iconic charred edges and tender, juicy center. Factory grills are designed to cook hundreds of skewers at once, while ensuring each one gets that perfect sear. And here we have a fully automated industrial bakery line that ensures efficient bread production. After baking, loaves move onto cooling spirals where they slowly cool to the right temperature. Next, automated bread slicers cut the loaves evenly before they reach the bagging machines. These machines quickly place the sliced bread into bags, seal them, and label them for distribution. The entire process is fast, hygienic, and ensures fresh, high-quality bread for consumers. And here we have the process of making burger buns. It all begins with selecting high-quality ingredients. The main components of burger buns are flour, water, yeast, sugar, and butter or oil. Once the ingredients arrive, it's time to mix the dough. Large industrial mixers combine ingredients in precise quantities. After mixing, the dough is divided into perfectly portioned pieces. These pieces are shaped into buns using automated machines. At this stage, the buns may also receive a dusting of flour or sesame seeds, depending on the type of burger bun being made. Once shaped, they are sent to the proofing chamber. This is a warm, humid environment where the dough rises for the final time before baking. Next up is the baking process. The buns bake at high temperatures until they turn golden brown. This step requires precise timing and temperature control to ensure that they are perfectly baked. During baking, the yeast creates bubbles in the dough, giving them their signature soft texture. After baking, the buns need to cool down before they can be packaged. They are transferred to cooling racks where fans help bring them to room temperature. Once cooled, they are ready for packaging. In the packaging section, buns are placed into plastic bags or other packaging materials to keep them fresh. Automated packaging machines ensure the process is fast and efficient. This factory makes thousands of doubler chocolate bars every day using a smooth and efficient process. First, melted chocolate is poured into molds on a conveyor belt where it takes the shape of the classic doubler bars. The bars cool and harden as the belt moves along. Once solid, they are carefully removed and wrapped in shiny foil or paper to keep them fresh and tasty. Finally, the wrapped bars are packed into boxes ready to be sent to stores. There's nothing quite like a well-baked croissant with that crispy and soft in the middle, with the subtle flavors that melt in your mouth. However, croissant production must be done just right, especially when you're producing them on a high-speed line. The journey of a croissant begins with its ingredients. Factories use premium flour, rich butter, sugar, yeast, and a touch of salt to ensure consistent quality. The dough is mixed in large industrial mixers, where it transforms into a silky base, ready for the next crucial step. One of the defining features of croissants is their flaky and layered texture. This is achieved through a process called lamination. Large machines roll out the dough into thin sheets and layer it with chilled butter. The dough is folded and rolled multiple times, creating up to 27 layers of dough and butter. These layers are the secret behind the croissant's crisp exterior and airy interior. Once the laminated dough is ready, it's chilled to maintain the butter's integrity. The sheets are then cut into perfect triangles to create that iconic shape of croissants. Automated systems roll these triangles into crescents, a process that's both precise and mesmerizing to watch. Proofing is a critical step in the croissant-making process. The croissants rest in a controlled environment where the yeast activates, causing the dough to rise and develop its light and airy structure. Temperature and humidity are carefully monitored to ensure the croissants proof evenly, creating that perfect texture. Once proofed, the croissants are ready for baking. Industrial ovens bake them at precise temperatures to ensure even cooking. This is where the butter melts, creating steam that forms the iconic flaky layers. In just 20 to 25 minutes, the croissants emerge golden, crispy on the outside, and soft on the inside. Every croissant undergoes strict quality control to ensure consistency. Only the best croissants make it to the packaging line, The ones that don't meet the criteria are removed, ensuring only the best reach the customer. Modern packaging systems carefully wrap the croissants, sealing in their freshness. These systems can package hundreds of croissants per minute, ready to be shipped to bakeries and stores. From a pharmacy on the streets of Atlanta to a global phenomenon, Coca Cola has captured the world's taste buds. With an astounding 10,000 servings enjoyed every second, this iconic drink has become more than just a beverage. It's a symbol of refreshment and nostalgia. The production of Coca Cola begins with the main ingredients include water, sweeteners, like sugar or high fructose corn syrup depending on the country, caffeine, and a blend of natural flavors. The exact combination of flavors is a closely guarded secret, often referred to as Merchandise 7X. While most of the ingredients are common, the proprietary flavor mix is what sets Coca Cola apart, giving it a unique taste that has been cherished for over a century. The process begins with purifying the water, which is the primary component of Coca Cola. Factories use advanced filtration systems to remove any impurities, ensuring that the water meets Coca Cola's high-quality standards. Purified water helps maintain a consistent taste, regardless of where in the world the drink is produced. After water filtration, it's time to make the syrup base. This syrup is the concentrated form of Coca Cola that will later be mixed with carbonated water. The purified water is combined with sweeteners and the proprietary flavor blend in large stainless steel mixing tanks. Automated machines measure and mix these ingredients with precision to ensure consistency. Quality control is crucial during this stage, as even a slight variation could alter the drink's iconic flavor. The syrup base is continuously tested for taste, consistency, and quality. Once the syrup base is ready, it's time to add the fizz. Carbonation is what gives Coca Cola its refreshing bubbles. This step involves pumping carbon dioxide gas into the syrup base under high pressure, creating the signature effervescence. The amount of carbonation is carefully regulated. Too much or too little could change the experience of drinking Coca Cola. This is done in large carbonation tanks, ensuring that the gas mixes evenly throughout the liquid. While the syrup is being prepared, the factory also produces bottles for the beverage. Coca Cola bottles can be made from either glass, plastic, or aluminum. Quality control is a top priority for Coca Cola, as consistency in flavor and quality is key to the brand's reputation. Throughout the manufacturing process, samples are taken and tested to ensure they meet Coca Cola's rigorous standards. Technicians test for taste, carbonation levels, and purity, ensuring each batch of Coca Cola matches the brand's standard. Each bottle or can is carefully inspected for any defects before filling. Modern quality control technologies such as high-speed cameras and sensors detect any imperfections. Only bottles that meet Coca Cola's quality standards move forward in the production line. The bottling process is a high-speed, automated operation. The carbonated Coca Cola syrup is poured into bottles or cans, typically at a rate of thousands of units per minute. These filling machines are designed to minimize any loss of carbonation and prevent any outside contamination. Immediately after filling, each bottle is capped to lock in the carbonation and preserve freshness. The capping process is quick, often happening within seconds of filling, and seals the drink tightly. The caps are made from special materials that maintain the seal while withstanding the pressure inside the bottle. Once filled and capped, each bottle or can is labeled with Coca Cola's iconic branding. The labels include important information such as ingredients, nutritional details, and the brand's trademark logo. This labeling process is also automated with high-speed machines applying the labels with precision to ensure they're aligned correctly and securely attached. After labeling, the bottles are grouped into cases and packaged for distribution. In most factories, Coca-Cola products are packed in cardboard boxes, plastic-wrapped, or pallets, making them ready for transport. Some factories also produce multi-packs for bulk buying, ensuring they can meet various customer needs. Once packaged, the finished products are ready for distribution. Coca-Cola uses a vast network of logistics to transport the drinks from the factory to distribution centers, and then onto retail stores. Refrigerated trucks are often used to ensure the drinks are kept at optimal temperatures during transport. In just a matter of days, a bottle of Coca-Cola can go from production to being stocked on store shelves, ready to be enjoyed by customers around the world. Now, let's dive into the process of making banana chips in factory. It begins with selecting raw bananas, typically green plantains, which are firm and less sweet than ripe bananas. The bananas are sourced from local farms and transported to the factory for processing. The first step in the factory process is washing the bananas thoroughly to remove dirt and any residues. After cleaning, the bananas are peeled mechanically. Large-scale banana peeling machines are used to remove the tough skin without damaging the fruit inside. Next, the peeled bananas are sliced into uniform thin rounds. This is done using high-speed slicing machines that ensure consistent thickness. Once sliced, the banana rounds are deep-fried in large industrial fryers. The oil used for frying is typically heated to around 350 degrees Fahrenheit. The fryer is designed to maintain a consistent temperature and evenly cook the chips. The banana slices are fried in batches, ensuring they turn golden brown and crispy without absorbing excess oil. After frying, the chips are drained to remove any excess oil and then passed through a seasoning machine. Here, the chips are evenly coated with salt or other spices depending on the desired flavor. Finally, the banana chips are packaged in airtight bags to preserve freshness and prevent them from becoming stale. Once harvested, the shrimps delivered to the factory, where they are washed thoroughly in cold water to remove dirt, bacteria, and contaminants, helping maintain their freshness. The shrimp are then graded and sorted by size and quality. After this, they are deveined by making a small incision to remove the digestive tract, which improves both appearance and taste. Next, the shrimp are peeled, and depending on market preferences, some may have their tails left intact. In some factories, shrimp are further processed into breaded or seasoned products. This involves coating the shrimp with batter, breadcrumbs, or seasonings before frying them in hot oil for added flavor and texture. After frying or final preparation, shrimp are quickly frozen individually on conveyor belts to preserve freshness and ensure easy portioning. Finally, the frozen shrimp are weighed, packed into secure containers, and stored at low temperatures, ready for distribution to markets. Cutting meat is far more challenging than it appears. For years, factory workers handled this task manually, often risking injuries. Automated machines, like those designed by S Company from New Zealand, have revolutionized this process. Their systems use specialized disc blades that move and cut carcasses with precision, eliminating the need for manual handling. Automation ensures efficiency, consistency, and high standards. Advanced automation technology plays a crucial role in processing lambs safely and effectively. This technology reduces the risk of injury significantly. automated equipment handling these high-speed cuts, human hands are far from harm's way, making the workplace safer and more efficient. Let's take a look inside a factory where thousands of pancakes are made every day. Using fresh ingredients and advanced machines, the factory produces soft, fluffy pancakes that taste just like homemade ones. The process starts by mixing flour, eggs, milk, and sugar into a smooth batter. Machines then pour the batter onto large, hot griddles, cooking each pancake until golden brown. Some pancakes are kept plain while others are filled with chocolate, fruit, or syrup for extra flavor. Once cooked, the pancakes are cooled, carefully stacked, and packed to stay fresh. They are then sent to supermarkets and restaurants, ready for customers to enjoy. People can simply heat them at home for a quick and delicious meal. The production journey of almonds begins at the tree, where each stage plays a vital role in the nut's development. The harvesting process is initiated by evaluating the almond's maturity to ensure they are collected at the perfect moment for optimal flavor and nutritional value. Modern machinery, like the tree shaker, clamps onto the trunk or branches and gently vibrates the tree, causing the almonds to fall onto the orchard floor. Once collected, the almonds begin their transformation through several key processing stages. First, they are thoroughly cleaned to remove any dirt, leaves, or debris from harvesting. The next step is dehulling, where the outer hull is carefully removed, exposing the shell that encases the almond kernel. Following this, the almond shells are cracked open to extract the kernels, a delicate process that avoids damaging the nuts. Afterward, the almonds undergo an advanced sorting process to eliminate those with significant damage or defects. Once sorted, the almonds are packaged and sent to stores. Some almonds, depending on market needs, undergo further processing to enhance their flavor, texture, or nutritional value, ensuring they meet diverse consumer preferences. This meticulous journey from tree to final product highlights the care and precision involved in producing almonds for various uses in both raw and processed forms. Honey production is a blend of traditional beekeeping practices and modern technology that involves several key steps and processes to ensure high quality and efficient production. The journey of honey begins in the beehives, where bees collect nectar from flowers and transform it into honey. Beekeepers monitor the hives to ensure the bees are healthy and productive. Once the bees have filled the honeycomb cells with honey and capped them with beeswax, the honeycomb frames are carefully removed from the hives. This is typically done using a gentle smoking process, which calms the bees and allows the beekeeper to work without disturbing them. The first step, the factory, is to remove the thin layer of beeswax that seals the honey inside the comb. This process, called uncapping, can be done using special uncapping machines or manually with a heated knife. The beeswax collected during uncapping is often used to make products like candles or cosmetics. Once the honeycomb is uncapped, the frames are placed into a honey extractor. This is a machine that spins the frames at high speeds, using centrifugal force to extract the honey from the comb without damaging it. The extracted honey is passed through filter to remove impurities such as bits of wax, bee parts, or other debris. Once processed, the honey is pumped into jars, bottles, or other containers. Automated filling machines ensure that each container is filled to the correct level, and then they are sealed to maintain freshness. Over 10 million tons of butter are consumed worldwide each year. But how does fresh cow's milk transform into the rich, creamy butter we love? In this video, we'll take you inside the fascinating world of butter production, from separating cream to churning and packaging. Butter may have been discovered by accident when cream was stirred too much, possibly as far back as 10,000 years ago. However, it wasn't until the Industrial Revolution that butter became widely available in households. The ancient Romans used it as a beauty treatment and to heal burns. In earlier times, people made butter by shaking milk in animal skin bags or hollow logs. Then, in 1878, Carl Gustav Patrick invented the mechanical cream separator, making large-scale butter production possible. Today, half of the 570,000 cows on Danish dairy farms provide milk for butter production. High-quality butter comes from cows that graze on fresh pasture. Since butter is made exclusively from cream, the first step in production is separating the cream from the milk. The world's largest butter company produces 154 tons of butter every day. The process begins when a tanker truck delivers about 30,000 liters of fresh cow's milk to the dairy. When the milk arrives at the factory, it undergoes strict laboratory testing. Workers check its color and smell for consistency before pumping it through vacuum-sealed hoses into a separator. This machine spins rapidly, using centrifugal force to separate the milk fat from the liquid. The fat, known as cream, collects in the center while the skimmed milk moves outward. The cream, which is thick and whitish with about 38% fat, is the key ingredient in butter. Some of it is also used to produce lower-fat milk alternatives. The less fat, the thinner and more fluid the milk. The centrifuge spins at 1,500 revolutions per minute, ensuring efficient separation. The cream and skimmed milk exit through separate pipes, and the fresh cream is then transported in tankers to the butter factory. Each day, tankers carrying 25,000 to 30,000 liters of cream arrive at the factory. To eliminate harmful bacteria, the cream is heated to 92 degrees Celsius for 15 seconds, a process known as pasteurization. It is then transferred to bulk tanks, where mixers keep it well blended to ensure consistent quality year-round. However, the composition of cream changes with the seasons. In winter, cows graze on fresh grass, which leads to softer butter due to higher unsaturated fat. In summer, when fresh grass is scarce, the butter becomes firmer due to increased saturated fat. To maintain a uniform texture, the cream undergoes a two-stage process called maturation. First, the cream is heated in tanks to 15 to 20 degrees Celsius, then pumped into a 150-ton tank and slowly cooled to 9 degrees Celsius. This process alters the fat crystals, ensuring a consistent texture year-round. After maturing overnight, an operator checks the pH and flavor. If the cream is too acidic, it means it's spoiling, and the entire batch must be discarded. At this stage, the cream is still a liquid. It needs to be churned to become butter. After 24 hours of pasteurization and maturation, workers transfer the cream to a machine called a churn. First, they clean the churn by filling it with water mixed with iodine to kill any germs from the previous batch. It spins for about 5 minutes before being rinsed with water. Next, they pour in 1,500 liters of cream, filling the churn halfway. Leaving space is essential, as air released during churning must escape through 2 vents. The churn spins at 1,000 revolutions per minute and can hold about a ton of butter. Churning breaks down the fragile membranes surrounding fat droplets in the cream, allowing the fat to clump together into soft, buttery pieces, known as popcorn. Every 5 minutes, an operator pauses the mixer to release excess air. Once no more air escapes, the valve is closed and churning resumes. After 30 minutes of churning the fat molecules in the cream clump, together forming creamy pieces. These clumps remain in the churn while the liquid known as buttermilk drains out, and is later used to make cream cheese. Each hour, 12 tons of buttermilk are removed, leaving behind only the butter clumps or popcorn. At this stage, 2 final ingredients are added. An operator seasons the butter with 14 kilos of salt and a lactic acid culture. The bacteria in the culture ferment the lactose-producing lactic acid and natural aromatic compounds. This gives the butter its slightly tangy taste and familiar aroma. During churning, air bubbles get trapped in the butter, which can cause oxidation and an unpleasant metallic taste. To prevent this, the worker seals the mixer's window with a rubber ring and metal clamp, maintaining stable air pressure inside. The butter is then kneaded to blend the ingredients before being sent to a vacuum chamber, where any remaining air is removed. Now the butter is ready. A worker transfers about 30 kilos of it into a mill, which shapes and packages it. The machine presses the butter into a block-shaped injector, which deposits it into open containers. The packaging paper has an aluminum outer coating to block light, preserving the butter's quality. Each sheet of paper measures 26.5 centimeters by 19 centimeters. The factory operates 4 days a week, producing up to 230 packets of butter per minute.